Okay, class. Actually, I already give you second order linear differential equations, both notes in PDF format and slide records. But for VPM, I think that suara dia putus-putus kan, so that I come up with a solution of taking a new video on YouTube. I already uploaded on YouTube, which is variation of parameters. VPM is a quite popular questions on final exams or any examinations. Okay, so for our discussion today, we want to discuss, actually not discussion, I want to know what is your problem before we go to the second order. I just want to know what is your problem. Anyone nak start dekat mana? We have second order linear differential equations. First, you must understand that the standard equation is given by, kenapa yang ni tak boleh hilang is given by, wait, the standard equation is ay double prime plus by prime plus cy equals to fx. Okay, and our fx can be 0 or non-zero. If fx is 0, we call this equation as homogeneous, and if your fx is non-zero, so that we have UCM or VPM to solve the problem. UCM and VPM can only solve for constant coefficient of second order non-homogeneous equation, which means that you must have this kind of equation. Then only you can solve by using UCM or VPM. After we finish VPM, you will notice that, okay, we have another equation which is in the form of this one. Ax squared d square y dx square plus bx dy dx plus cy equals to fx. Okay, so that if you look at this equation is not constant coefficient anymore because we have x squared and x inside your equation. So this equation, we call this equation as second order linear differential equation with variable coefficients. Okay, so this one is constant coefficient, and this one is variable coefficient. And we call this equation as Cauchy-Euler equation. If you look at the notes and my video, I told you this Cauchy-Euler equation cannot be solved by using UCM and VPM. Why? My question is why. Okay, this is true false question. Can Cauchy-Euler equation can be solved by using UCM and VPM? This one. The answer is, if you have this kind of equation, therefore we cannot solve this equation by UCM and VPM. Why? Okay, tell me why. The reason is because UCM and VPM can only solve for constant coefficient only, not variable coefficient. But, ada but pula. But, we insist want to solve the Cauchy-Euler equation by using UCM and VPM. How? My question is how? A. Initially, we know that UCM and VPM cannot solve this equation because this equation involves variable coefficient. But we still want to solve this equation by using UCM and VPM. The question is how? The answer is, you need to make this equation, the variable coefficient, into constant coefficient. Okay, you might ask, how we can transform a variable coefficient into the form of constant coefficient? How? Okay, you must do one substitution. Let x equals to et or t equals to ln x, natural log x, okay? And then try to substitute into this equation. Then this equation will become this one. A d square y dt square. Look, initially you have y and x here, but after you replace x with et, t, so that your equation becomes t lah, plus b minus a dy dt plus cy equals to, initially you have fx here, fx, but x is replaced by et, so you have fe. You will find that the latter equation is in the form of constant coefficient. Therefore, we will solve Cauchy-Euler equation, this one, by using UCM or VPM, if FET not equals to 0. Okay, so that is the synopsis of second order. So now I want to know your understanding or what you don't understand and what is your current problem on homogeneous dulu. We go one by one. First, homogeneous, and then I want to know your problem on UCM. Okay, UCM case 1, case 2, case 3, case 4. Then I want to know your problem on VPM. And last is Cauchy-Euler. We go homogeneous first. Anyone? Ali ada? Ali speak up. Ali?
Dia kena cakap fokus Ali baru dia keluar.
Ali, fokus Ali. Ali. Oh, kuat pula aku ha. Cepat. Tak keluar pun Ali ni. Dia buat kerja lain ke?
Okay. Ali Isak Medan, dia problem nak join Webpack, dia tengah create account dia kata.
Oh ya ke? Alamak, sianya.
Line slow sikit.
Okay. Kalau macam tu, I want to ask Abdullah Saleh Bawazir. Sebab nama dia dekat sini kan. Abdullah? Hi yes. Abdullah. Okay Abdullah, I want to know how you can solve for homogeneous equation this one. Bunyi flash ke tu? Abdullah?
Yes.
Okay, so how you can solve this one, Abdullah?
We need to use that table, I think.
What you need to do here? Okay, my first question, Abdullah. Is this homogeneous or non-homogeneous equation?
Yes, it's homogeneous.
Homogeneous. Why you say this one is homogeneous? Why? Anyone?
Because it's same like A and D square root 2 y.
Abdullah, I ask you why you say that this equation is homogeneous equation. Why? Why? The answer is because fx equals to 0. Okay, class.
Oh.
Some tips for your test 1 as a preparation for your test. You must be able to understand the fundamental of second order, which is, for example, just now, I can give you multiple choice question. My question is very simple. Given that this one, y double prime plus 4y prime plus 3y plus 0. Okay. And then my question is, homogeneous equation. Why that this one is homogeneous equation? So I give you the list, the option of the solution. So must choose the one of the possible answer is fx.
Madam, cannot hear you clearly, madam.
Tak boleh clear. I dengar macam
I heard someone at stadium right now.
saya macam broadcasting juga. Mana bunyi tu? Bunyi apa tu? Alright. To solve for this one, how we can solve for this one? So the first
Tutup mic Chin.
we must reduce this equation or transform this equation in the form of characteristic equation. What is the tell me what is the other name of
Medium tak function dah bising.
siapa yang bising ni?
Just bising.
Sing you sing.
Okay, guys. And what is the other name of characteristic equation? Takut nanti bila when I ask you the multiple choice question, find characteristic equation. Oh, name. So the other name is this one. I want you to remember this one. I already told you in class. Auxiliary equation. Just the same thing. And then we need to find out the roots. Kan?
Madam, suara madam tenggelam, madam.
Madam, ada dengar madam. Ada orang buka mic kuat sangat madam.
Yang King Yusu tu madam. Kik kan madam? Macam dia tak ada ni.
Kik dia madam. Bising.
Macam-macam
Kik dia. Perhatian kepada Chin Yusu Win. Please mute
Sing
your
you
mic.
sing.
You don't understand. Please use other language.
Okay, madam.
Okay.
Dia cakap English cukup.
So we have b square minus 4ac. You must check. Is it greater than 0, less than 0, or equal to 0? Okay. This one you must mastering this one because this is the very very basic lah. So you need to understand on how you can get the solution of homogeneous solution. Okay. Sometimes the question is easy, but since we have multiple choice question, right? So we always like to trick you on the solution or trick you on the question. So please read carefully, okay, and please choose your solution wisely. Okay, so this one is b square minus 4ac is obviously greater than 0. You must have two different roots. When you have two different roots, in nature you will have a e m1x plus b e m2x. Okay, so you have m3 plus 1 plus, so you get 4m here. So you have two different roots, m equals to -1, m equals to -3, so the solution is yh. ae m1x x, okay? E negative x plus BE negative 3x. So this is homogeneous equation. If we have B square minus 4AC less than 0, please always use the formula of finding the roots. This one. Okay? And I want you to understand that, okay, the solution of YH will always A Y1 plus B Y2. Okay, where Y1 and Y2 are the solution that you get from your M here, EMX. Okay, so from this solution YH, what you can say about your Y1? What is your Y1? Okay, our
E power negative x.
is E negative X. Good. Our Y2 is E negative 3X. Okay, let's say you calculate and then you come up with the solution AE2X plus BXE2X. So tell me what is your Y1? Y1 is
E power to 1.
E2X. Your Y2?
E power to x.
Y2 is you must take X E2X.
X bar x equal.
Yes. Okay. So again, if you have exponent 2x, A cos 3x plus B sin 3x. So tell me, what is your Y1?
E power to x cosine 3x.
E2x cosine 3x. Your Y2 is E2x sin 3x. The selection of Y1 and Y2 are very important in order to solve your non-homogeneous equation by using variation of parameters method. Clear? Clear?
Yep.
Okay. So, next. Lagi Okay. That is homogeneous. I want to go to UCM. Before that, anyone got problem on homogeneous equation? Please ask now.
Homogeneous equation dia sama dengan kosong tu kan, madam? Itu je kan nak tahu dia homogeneous.
Yeah, dia AY plus BY prime plus CY equals to 0. Then you reduce the equation in the form of characteristic equation. Find your check the nature of your M, two different roots ke, two equal roots or two complex roots, and then you must come up with the solution YH equals to AY1 plus BY2. A and B consistent, but your Y1 and your Y2 can be determined from your nature of your roots lah, B square minus 4AC tu. Okay, please check your notes on homogeneous. Clear? Homogeneous? Clear?
Yeah.
Okay. We go to UCM. UCM is a method to solve for the same thing. AY double prime plus BY prime plus CY equals to FX. But this time, your FX is non-zero. Okay. Y can be obtained by finding your YH and YP. Okay. Y is the solution that we want to find. How to get Y? Y can be obtained by finding your YH and YP. Where YH come from your homogeneous solution? YH is AY1 plus BY2 just now. Okay. Right. Then our YP comes from the particular solution where we need to consider the whole equation here. But for UCM, This is strictly for 3 main cases only. Case 1, case 2, case 3. Okay, this one, case 1, your fx in the form of polynomial of degree n, di mana n greater than 0 or equals to 0. Okay, for example, case 1. Let's say you have a, no lah, bagi soalan terus. Let's say you have a question of y double prime plus, ambil soalan tadi dah, 4y prime plus 3y equals to x square. My question is, can this equation be solved by using UCM? Can or not?
Can, madam.
Can, madam, can.
Give me 2 reasons. Reason 1. Reason
The
1.
one that the coefficient is only constant.
Okay, because the reason 1, because A, B, C are all constants and this equation does not involve any variable, right?
Yes, sir.
Okay. The second reason,
It's equal to fx, not equal to 0.
because your
X equal
fx is non-zero
x square.
and have
0.
polynomial of degree 2.
Okay.
Okay, so that is the reason. Let's say if I have this one, x equals to negative 2 here. Can you solve this equation by using UCM? Can or not?
Which one again?
If I change this equation into the form of equals to x to the power of negative 2, tell me, either you can solve this equation by using UCM or not.
I think yes.
Why Hossam said yes?
When it's to the n degree, it's doesn't matter the negative or positive sign for the power.
So you said that this one is still in the form of polynomial, right?
Yeah. No, it's exponential.
Okay, so I want to ask siapa lagi ada kat sini? Afiq. Just to make sure that Afiq tak pergi tandas ke, tengok Netflix ke. So please answer me. Is this equation can be solved by using UCM? Afiq?
Boleh.
Boleh. Why boleh Afiq? Why can? Entahlah madam, ikut perasaan saya je madam. Boleh lah kot. Afiq? Akmal? Can this equation can be solved by using UCM? Mana nak murid aku ni hilang? Akmal? Muhammad Akmal?
Sebab dia tak sama dengan kosong madam.
Memang, tapi tadi my question is when your fx is x square, right? Yes, we can solve this equation by using UCM. Then now I add up this one. If your fx is x to the power of negative 2, can you solve this equation by using UCM? Muhaimin,
Tak boleh.
kenapa tak boleh ke boleh?
Tak boleh.
Kenapa tak boleh Muhaimin?
Sebab dia negatif kot.
Okay. The answer is cannot. Because UCM can only solve for polynomial of degree n where here, this one, n is equal to 0 or greater than 0 only. But this one, your n is less than 0. So that is why we cannot solve this
Oh, I see.
UCM. If I give you MCQ, multiple choice question, true or false, you said that this one is true, so that you will lose 1 mark. 1 mark. Habis. So this is kind of MCQ for your test. Okay? You must understand very well the little thing lah yang macam ni. Okay, the condition of each of the cases. Okay? Understand? So we cannot solve this equation by using UCM. My question is, can we solve this equation by using VPM? VPM. This kind of question. Can or not?
Wow. Boleh kot. Tak boleh, tak boleh.
No, bukan boleh kot. Not boleh kot. VPM is more powerful than UCM. VPM can solve any kind of second order linear differential equation with constant coefficient, then you have homogeneous equation. Okay? VPM memang boleh. Okay? Alright. So, next. Let's say for case 2. For case 2, in order to use UCM, your fx must be in the form of CEKX only, where C and K are constants. For example, you have y double prime plus 4y prime plus 3y equals to 4e negative 2x, where your C here is 4, okay? And then your K is negative 2. Both are constants, so that this equation can be solved by using UCM. But if I change this equation in the form of 4e negative 2x square, for example, so that your fx here is no longer in the form of CEKX. Apa tu? So punya apa weh? So that we cannot solve this equation by using UCM because your fx, yes, because your fx is not in the form of CEKX anymore. Understand? Next. For case 3, your fx must be in the form of trigonometric function, but strictly in the form of c cos kx or d sin kx, or the combination of sine and cosine only. If you have y double prime plus 4y prime plus 3y equals to 2 sine 3x, where your d is 2, your k is 3, still constant, and it follows the standard the condition of your fx. Therefore, we can solve this equation by using UCM. Let's say if you have your fx equals to 2 sine, tak naklah sine, I change, 2 cotangent 3x. Even though cotangent still in the form of sine and cosine, but it is not in the form of c cos kx or d sin kx or the combination plus minus of sine and cosine. Cotangent is, if you have the question of cotangent, therefore you cannot solve this equation by using UCM. Okay, only the basic is the 3 main cases only. Polynomial of degree n, CEKX, and trigonometric function sine and cosine. I want to ask you, if you have ay double prime plus by prime plus cy equals to fx, then your fx is x square natural log x. X square natural log x lah. My question is, can you solve this equation by using UCM?
Cannot.
Why cannot?
No.
Pak dia lawn.
Yes, because of this one. Okay, so that we cannot solve this kind of equation by using UCM. Boleh? Okay. Ini sebenarnya saya dah beritahu.
Okay.
Lagi apa lagi nak tahu? I don't want to calculate because the calculation is panjang kan?
Dia kalau cos ataupun sin dia betul kan Madam Wen?
Yes, sine or cosine only. Dia mesti dalam bentuk fx. Your fx is c cos kx or d sin kx or c cos kx plus or minus d sin kx. So that we can get yp. Yp equals to x to the power of r. Just letak c cos kx plus d sin kx where r 0, 1 until up to 2. That's all. Tu je. And you must remember the step of solution lah. I don't want you to remember. I want you to understand the step of solution to get the solution. So, nak discuss apa lagi dalam UCM? Dekat mana yang selalu stuck? Or you find that, oh, I really don't understand how to get the solution of YP. I don't understand how I can compare the terms in order to get the constants. Okay, tanya sekarang. Okay. Okay, nak tanya apa?
Kalau dia ada per tu macam mana?
Kalau per, oh, for example, cotangent. Cotangent macam mana dapat? Tangent, sine over cotangent is cosine over sine, right? So we cannot solve by using UCM. Let's say you have A, Y double prime. Kenapa tulisan ni jadi macam ni Sebab ada orang yang notate kat sini. Siapa yang notate saya ni? Mana aku nak conteng dia? Okay, for example, if we have Y double prime plus 3Y prime plus 4Y equals to X over X plus 1. Nampak? Equals to X over X plus 1. So, we cannot solve this kind of equation by using UCM juga. Tak boleh. So, nak guna apa? So, what is the alternative method to solve that kind of question? The answer is variation of parameters method. Okay? Mana Mak Saleh ni? Dia conteng kat mana ni? Dia annotate saya lah. Dia buat kat sini so that cannot. Okay. Nak tanya apa lagi? Okay, yang warna kuning tu, okay. Mana aku nak drag? Tolong drag ke bawah sebab saya rasa saya macam tak boleh drag ke bawah. Macam mana aku nak drag ni? Yang warna kuning tu, okay.
Saya nak tanya, kalau kita guna case 1 juga untuk selesaikan persamaan tu, apa akan jadi?
Okay, case 1, this one, A y double prime plus 4y prime plus 3y equals to x square just now. Or x to the negative, x to the power of negative 2.
Ya.
Macam mana? Oh, ni yang Sabah tu ya? Macam mana soalannya tadi?
Indun. Kau sabar.
Serius ah?
Kenapa kita tidak boleh selesaikan persamaan?
Kenapa?
Kenapa kita tidak boleh selesaikan persamaan tu menggunakan UCM case 1, walaupun case 1 tu dia punya dia punya polinomial dia tu perlu lebih dari kosong. Apa akan jadi kalau kita guna juga case 1?
If you have polynomial of degree n, where your n is equals or greater than 0, you can solve that equation by using UCM, case 1. But if you use, if you have a polynomial of degree n, where n is less than 0, in short, you have the negative degree lah, you cannot solve by using UCM. The question is why? Because how you want to start your YP? YP equals to x to the power of r, so that you will have cx to the power of negative, x to the power of negative, and then goes to where? Goes to until up to n yang berapa? Faham tak? If you have polynomial of degree n, where n is equals or greater than 0, for example, we have n, degree of n is 2, so that you have, for example, you have x square. So your YP is cx square plus dx plus e. So you have the highest degree is 2, goes to 1, goes to 0. But if you have the degree of negative, we don't have the negative degree in solving your DE by using UCM. So that is the answer. You cannot solve by using UCM if you have polynomial of degree n where n is less than 0. It's not valid. Not valid, and UCM fail in that question. But you can solve the question by using VPM only. Itu je. Okay? Saleh?
Okay.
Alright. So that is UCM. The most important part is you understand on how to get the homogeneous solution. And then, macam mana saya nak stop yang ni ya? Ada sesiapa tahu tak? Saya tak boleh nak gerakkan. Okay, dah boleh dah. Maafkan saya because this is my first time using Webex. Okay, alright. So class, can we continue to the next one?
Yes.
Okay.
Okay, Manoj.
Alright. So next is kita nak guna apa ni tadi? VPM, variation of parameters method. Variation of parameters method, the solution is still y equals to YH plus YP. But your YP this time around, we don't care about what type of your fx. Compared to UCM, in order to get YP, you need to consider either you have polynomial or you have exponential or trigonometric function, right? But for YP, in VCM, you can solve any kind of fx. The challenges are either you have a simple or difficult integration after this. Itu je. Okay, so YP is UY1 plus VY2. Where U and V comes from the formula U negative Y2 Fx over AW, integrate with respect to X, and then you have V equals to Y1 Fx over AW dx. After you get U and V, and then you can substitute here. U, V, Y1 and Y2 comes from your homogeneous solution. If you still remember, we have discussed just now. YH equals to A, Y1 plus B, Y2. We are not taking the the A and B. We just take whatever function next to your A. That is your y1. Whatever function next to your B, that is your y2. So substitute here. y1, y2, simple. If you look at the formula of u, you have y2. Okay, y2 can be obtained from here. Fx can be obtained from the question. Your question is ay double plus by prime plus cy equals to fx. So take your fx and bring it into the formula here. Okay, y1 you can obtain from your y1. A can be obtained from your question A here. Okay, and w is the new thing. W, we call W as Wronskian. Wronskian W can be obtained by calculating. Put your y1 here. Below y1 is the first derivative of y1. Next to y1 is your y2. Below y2 is the first derivative of your y2. And then we just cross. Macam, this is just like if you want to find the determinant. But if you get positive or negative sign of your solution, just leave it. If you get positive, positive. If you get negative, don't make it modulus. Okay? It means negative. So y1 times y2 prime minus y1 prime y2. So that is your Wronskian. After you get your Wronskian, substitute here to your u and v. That's it. VPM. So, in order to solve your equation by using VPM, first find YH, obtain YH first. After that, determine what is your Y1 and Y2. Okay. The next step is find Wronskian. And for find U and V. Finally, your solution is Y equals to YH plus UY1 plus VY2. So that is the step of solution. The difference, the challenge is by using VPM is here. This is the challenge. Either you have simple integration or difficult integration here. Okay. Any question? I show you how the method works, but I
No,
didn't
thank
use
you,
any
madam.
example. Okay. But I want you to do a lot of exercises on VPM. Okay. If I have time, I try to create quizzes for you, and then you try to answer the quizzes as your exercise lah. Okay. Right. Any question on VPM? I told you according to our plan, I already informed you that our test on this coming Sunday, we will test your understanding and your ability on second order linear differential equation only on UCM and VPM only. When we talk about UCM and VPM, means that it also involve homogeneous equation. Okay, because in order to get the solution of UCM and VPM, you must understand on how to get the homogeneous solution first. So homogeneous, non-homogeneous, UCM, VPM. That's it. That's all. We don't have Cauchy, Euler and multiplication questions. Clear tak?
Yeah.
So if you want to,
Okay, madam. Good.
if you want to put focus. So homogeneous, go to homogeneous, UCM and VPM. I want you to really understand on how to get the solution. If you have b squared minus 4ac equals to 0, what kind of roots that you have? Oh, b squared minus 4ac greater than 0, I will have two different roots. Okay, that is the idea that you need to understand. That is the basic. That is what I mean with basic. Okay, so basic to basic. So you must master all the basic things, okay, so that you can answer your test confidently. Memang confident lah boleh jawab test. 20%. Okay, I would like to open for question and answer for second order.
Madam,
Ya, yeah.
dekat round scan tu kan, W tu, kan
Okay.
kita dapat Y1 prime tu kan?
Ah,
Y1 prime tu kan? Okay, tu kita kena differentiate daripada Y1 atas tu lah.
yes, betul. So let's say your solution is, okay, let's say your solution is YH equals to AE2x plus BE negative 3x, for example, okay? So we set, this is my Y1, this is my Y2, okay? So the second step is determine Y1 and Y2, right? So I say that this one is my Y1, this one is my Y2. So the next step is find Wronskian. Wronskian, just letak Y1, this one is Y2. Below Y1 and Y2 are the first solution. So you have 2e, 2x, negative 3e, negative 3x. Just write like that. So cross. Tu je. So this one times this one, so that you have negative 3e. You have 2 times negative 3. So 2 minus 3. So you have negative x. Minus this one, so you have minus 2e negative x. So we have negative 5e negative x. Probably, maybe some of you will write this one. AE negative 3x plus BE 2x. It doesn't matter. But for your Wronskian, you will get like this. But after you get solution 1 equals to YH plus UY1 plus BY2, at the end of your solution, you will get the same thing. Tu je. If you change lah, terbalik ni kan. If you swap the position of Y1 and Y2, the selection of Y1 and Y2, so your Wronskian, your U and V will alternate positive and negative sign. Itu je. But at the end of your solution, Y equals to YH plus UY1 plus BY2, you will reach the same solution. Sama. Ada tak lagi nak tanya?
Madam dekat W tu